we're doing worksheet number 11A, which is average speed, and we're discussing the numerical problems related to average speed. Okay, so the first question says a car travels at 108 km per hour for 20 seconds. Calculate the distance for the car. The distance the car travels, give your answer in meters. So there are many issues with units in this question. This is per hour, this is in second, then this is in kilometer, and the final answer is asked in meters. So we need to keep the units in check. So first we need to find the distance. The formula for speed, distance, time is speed is equals to distance over time, which means distance equals speed into time. Speed is 108 km per hour. So the time needs to be changed into hour as well. To change seconds into hours, we divide it with 3600, because 60 times 60 is 3600. When we divide 20 with 60, we get answer in minutes, and again we need to divide it with 60 to get answers in hours. So we directly divide it with 3600. So 108 times 20 divided by 3600, this gives us 0.6 kilometers. Because the speed was in kilometers per hour, but we need the answer in meters, so we divide it with 1000 and we get 600 meters. Question number 2. A Mars cycles at a speed of 18 kilometers per hour. It takes him 55 minutes to cycle between two villages. Calculate the distance between the two villages. Again, this is in minutes and this is in per hour, so need to fix the units. So in the end we need distance. Distance is speed is distance over time, so distance is speed into time. Speed is 18 kilometers per hour. Time is 55 minutes, change it to hours, so we get 55 over 60 hours. So 18 times 55 over 60 gives us 16.5 kilometers. Question number 3. Two ports LP are 248 kilometers apart. So we have a port L and a port P, which are 248 kilometers apart. The ship leaves L at 20:45 and travels at a speed of 40 kilometers per hour. So the speed of the ship is 40 km per hour. Calculate the time the next day that the ship arrives at P. So first we need to find the time it took the ship to go from L to P, and then we'll add the time to 20:45 to get the time on the clock. So time is distance over speed. So distance is 248 and speed is 40 km per hour, so we'll get the time in hours. So 248 divided by 40 is 6.2 hours. Now if you'll click this button, it will divide this time in hours and minutes. So you'll get press this button in your calculator. It has a dot and 3 commas. So you'll get 6 hours, 12 minutes and 0 seconds. So add 6 hours and 12 minutes to the given time and we should get the answer. So add 6 hours and 12 minutes to this time, plus 6 hours 12 minutes. So let's do that. Let me grab another color. So 20:45 plus 6 hours 12 minutes. So this becomes 5, 6, 7. This becomes 5 and this becomes 26. Now this is 26 means that we're crossing the 24-hour clock limit, which means we're going into the next day. So subtract 24 hours from it and we get 257, and you'll write it as 0257 or 257 in the night, so 2:57 a.m., which is the answer for question 3. Question number 4. In the book, the distance between two planets is given as 4.07 into 10 power 12 kilometers. The speed of light is 1.1 into 10 power 9 kilometers per hour. Calculate the time taken for the light to travel from one of these planets to the other. So time is distance over speed. The distance is 4.07 times 10 power 12 kilometers over the speed is 1.1 times 10 power 9 kilometers per hour. So we'll get the answer in hours, which is by dividing these two, 4.07 times 10 power 12 divided by 1.1 times 10 power 9, which gives us 3700 hours. Now the question says to divide this into days and hours. So to change hours into days, we divide it with 24. So divide the answer with 24 and we get 154.1666 days. So we have 154 complete days and then some fraction of the days. So then you'll write 0.1666 and the remaining calculator display 667. Yes, 1.66666. So we have 5, 6 and then 7. So multiply this with 24 and we get 4 hours. Multiply this with 24 and we'll get 4 hours. So final answer is 154 days and 4 hours. Question number 5. A train travels for m minutes at a speed of x meters per second. Part A, find the distance traveled in kilometers in terms of n and x. So distance is speed over time. Speed is x meters per second. And then the time is m minutes. So we have a problem right here that this is per second and this is in minutes. So first they change m minutes to seconds. So we get 60 m seconds, right? So distance will be speed is x and time is 60 m. Oh, I wrote the formula wrong. Its speed is equals to distance over time, not this. So speed is equals to distance over time. So we need to find the distance. So distance will be speed into time. So the speed is x and the time is 60 m, sorry. And we're getting this answers in kilometers and we need to give the answers in sorry, we're getting this answer in meter because this is meters. So we're getting this in meters, but we need the answer in kilometers, so divide this with 1000. So we get 60 mx divided by 1000, which when simplified will give us this answer, 3 mx over 50. So for part B, we already have from part B that distance traveled in kilometers is 3 mx over 50. This distance will be in kilometers. So part B says when m is equals to 5, the train travels 10.5 kilometer, find the value of x. So simply substitute the values. Is equals to 3m is 5, x over 50. This should give us 35 according to the answer. Let's see, 10.5 times 50 divided by 15. Yes, we'll get 35. Next up is question number 6, which says that Liz takes 65 seconds to run 400 meter. Calculate her average speed in meter per second. So average speed is total distance over total time. Total distance over total time. Total distance is 400 meters and total time is 65 seconds. So divide these two and we should get the answer, which is rounded off answer will be 6.15. We round it off to 3 significant figures. Okay, next up is question 7, which says a train takes 65 minutes to travel 52 kilometer. Calculate the average speed of the train in kilometer per hour. So the time needs to be in hours. So first divide 65 with 60. This will give us 65 over 60. It is giving us a long number, 1.08 and 3 recurring. So next up is we have to calculate the average speed, which is total distance over total time. So total given distance is 52 kilometers and total time is 1.083 with a dot on it. So in your calculators you will do 52 divided by answer and we'll get 48 kilometer per hour. Okay. Then question number 8. Geneva and Hamburg are 864 kilometers apart. A plane flies from Geneva to Hamburg. The flight takes 2 hours 20 minutes. Calculate the average speed in kilometer per hour. So we're going from Geneva to Hamburg. Distance is 864 kilometers. Time taken is 2 hours 20 minutes. Calculate the average speed in kilometer per hour. So we need this in hours. This would be 2 hours plus 20 over 60 hours, which will give us 2 plus 20 over 60 is 2.33333 hours. So 2.3 with recurring point on 3. So average speed is again total distance over total time. Total distance is 864 kilometers and total time is this 2.3333. So I will be entering in my calculator 864 divided by answer, which gives us 370.2857. Since we give our answer in 3 significant figures, so the answer is 370 kilometers per hour. Question number 9. Mr. Chan flies from London London to Los Angeles, a distance of 8800 kilometers. So from London to Los Angeles, the distance is 8800 kilometers. The flight takes 11 hours 10 minutes. So the total time is 11 hours plus 10 minutes. Work out the average speed of the plane in kilometer per hour. So average speed is total distance over total time. Now what is the total time in hours? 11 plus 10 by 60. So 11 plus 10 by 60 is 11.16 with a recurring dot on 6. So I'll write this here. In my calculator I'll enter 8800 divided by answer, and I get 788.059, and when I'll round it off to 3 significant figure, I'll just get 788 kilometer per hour. Question 10. Priyantha completes a 10-kilometer run in 55 minutes 20 seconds. Calculate Priyantha's average speed in kilometer per hour. So we need time in hours. So we have 55 minutes and 20 seconds. We need to change both of these in hours. So to change 55 minutes to hours, we divide it with 60, and to change seconds into hours, we divide it with 3600. Add these two and we get 55 over 60 plus 20 over 3600, and we get 0.92222222 hours. So the average speed is total distance, which is 10 kilometer, over total time, which is 0.92222 hours. So in your calculators enter 10 divided by answer, which gives 10.8 kilometers per hour. Question 11. A ship takes 2 hours 15 minutes to sail 74 kilometers from P to Q. Calculate the average speed in knots, and we're given a conversion from knots to kilometer per hour. So that means we need to find the average speed in simply kilometer per hour and then use ratios to get the answer in knots. So in kilometer per hour, this average speed will be total distance over total time. Now total time in hours will be 2 hours plus 15 by 60. This gives us 2 plus 15 by 60 gives us 2.25, and then 74 divided by 2.25 gives us 32.8, and with a recurring decimal on it, a recurring dot on it, and this answer is in kilometer per hour. Now we need to change it to knots, and we know 1 knot is equals to 1.85 kilometer per hour. So 32.88888 kilometer per hour will be equals to how many knots? So cross multiply this and we should get x is equals to 32.88888, which is the answer key in your calculator, divided by 1.85, which gives us 17.7777. So rounded off answer is 17.8. Question 12. Ahmed and Ali left for home at 15:40. The average speed of their journey of their 88 kilometer journey was 55 kilometer per hour. Work out the time at which Ahmed and Ali arrive home. So they leave home at 15:40, and their average and the distance is 88 kilometers, and the speed was 55 kilometer per hour. So we need to find their arrival time. First we need time. Time is distance over speed, which is 88 over 55. This will be in hours, so 88 over 55 is 1.6 hours. And when I'll enter this, I'll press this key, I'll get 1 hour 36 minutes. Now add 1 hour 36 minutes to 1540 and 1540 plus 1 hour 36 minutes. This gives us 6, 4, 5, 6, 7, then 6, 1, 16, 76, but 76 minutes don't make sense on the clock, so give 60 minutes, that is 1 hour, to 16, so we get 17, 16 here, which is the answer for part 12. Question number 13. Amol drives his truck at an average speed of 50 km per hour. He leaves at 0700 and arrives at 1115. Calculate the distance he drives. Okay, so we're doing 13B. 13A was probably from a different topic, so not included in the worksheet. So he leaves at 0700 and arrives at 1115. So the first thing we need to find is how much time has lapsed between 7 o'clock to 11:15. So what's the time? 7, 8, 9, 10, 11. So 4 hours, 15 minutes. Yes. So time lapsed is 4 hours, 15 minutes. Now let's change this time into hours. So we'll have 4 hours plus 15 by 60 hours, which will be 4 plus 15 by 60. This gives us 4.25 hours. Alright, next is calculate the distance he travels. So distance is speed into time. So the speed is 50 kilometers per hour and the time is 4.25 hours. So 4.25 times 50 is 212.5 kilometers is the distance. So this is for answer for 13B. Then 13C. Priya drives a van a distance of 54 kilometers. She leaves at 10:55 and arrives at 12:38. Calculate her average speed. So again we need the time lapsed between 10:55 and 12:38. So we have 5 minutes here till 11, then from 11 to 12 we have 1 hour, and then from 12 to 38 we have 38 minutes. So which means we have 1 hour and 43 minutes, which means 1 hour plus 43 over 60 hours, which gives 1.716666 hours. Now we need the average speed. Average speed is total distance, which is 54, over total time, which is 1.716666. So we'll do 54 over answer and we get 31.456. So rounded off answer till 3 significant figure is 31.5 kilometers per hour. Question 14. A car travels a distance of 1280 meters at an average speed of 64 kilometer per hour. So there's a unit conflict, kilometers per hour and meters. Calculate the time it takes for the car to travel this distance. Give your answer in second. Another unit conflict, we'll have to go from hours to minutes. So we need the time. Time is distance over speed. I'll use the distance 1.28 kilometers, so that one conflict is addressed, divided by 64. So we get time is distance 1.28 kilometers over 64. So time is 1.28 hours, but it's 0.02 hours. We need the answer in seconds, so we multiply this with 60 and again with 60, or directly with 3600, which gives us 72 seconds. Question 15. A train leaves Barcelona at 12:21:28 and takes 10 hours 33 minutes to reach Paris. Calculate the time in the next day when the train arrives in Paris. So we have 2:21:28. We need to add 10 hours 33 minutes. This becomes 8, 9, 10, 11. 1 carry 3, 4, 5, 6. 1 and 3. So 61 minutes means give 1 hour to the other side and we get 32 hours 1 minute. Now we have gone into the other days, subtract 24 hours from it and we get 1, 0 and 8. So this is the answer, 0801 or 8:01 a.m. This was 15A. 15B is the distance from Barcelona to Paris is 827 kilometers. Calculate the average speed of the train in kilometer per hour. So the average speed is, let me clear the screen. So we're doing 15B. The distance from Barcelona to Paris is 827 kilometer. Calculate the average speed in kilometer per hour. So the average speed is total distance over total time. So the time was 10 hours plus 33 over 60 hours. We need the time in hours. So this will give us 10 plus 33 over 60 is 10.55 hours. So write 10.55 here, and 827 divided by 10.55 and we get 78.3886. so rounded off answer till 3 significant figure is 78.4. Question number 16. The distance between Prague and Vienna is 254 kilometers. So distance is 254 kilometers, and the local time in Prague is the same as local time in Vienna. That means we don't have to apply any time adjustment. A train leaves Prague at 15:20 and arrives Vienna at 19:50 the same day. Calculate the average speed. So first we need to find the time lapse from between 15:20 and 19:50. So till 1600 we'll have 40 minutes. Then from 16 to 19, 17, 18, 19 we'll have 3 hours, and then another 50 minutes. So this is minutes, this is minutes. Let me recheck. From 1520 to 1600 we have 40 minutes, and then from 1600 to 1900 we have 3 hours, and then another 50 minutes. So the total time is actually 4 hours 30 minutes, which means 4.5 hours. So the average speeds formula is total distance over total time over 4.5, which gives us 254 over 4.5, which gives us 56.44444. So rounded off answer is 56.4 kilometers per hour. Question 17. The children travel 270 km to a camp, leaving at, so the distance is 270 kilometers, leaving at 0743 and arriving at 1513. Calculate the average speed. Again, we first need to find the time lapse. So from 43 minutes to 60 minutes we have 17 minutes, right? From 0743 to 0800 we have 17 minutes. From 8 till 15 we have, this is 13, it's looking like 73, this is 13. Then from 8 to 15 we have 9, 10, 11, 12, 13, 14, 15. We have 7 hours and then another 13 minutes. So in total the time lapsed is 7 hours and then 30 minutes, which means 7.5 hours. So the average speed is total distance over total time. So 270 over 7.5, which gives us 36 kilometers per hour. Question 18. Asif cycles a distance of 105 kilometers. On the first part of his journey, he cycles 60 kilometers in 2 hours 24 minutes. On the second part of his journey, he cycles 45 kilometers at 20 kilometers per hour. Find the average speed for the whole journey. So average speed is total distance, which we know is 105 kilometers, and also total time. So we need the total time of the journey. So yes, so we need the total time. We have the total distance. So average speed is total distance over total time. Total distance is 105 kilometers. We don't know the total time, so we can find the time using the given data. The time for the first part of journey will be found from these two, distance and we actually have the time for the first part of the journey. It is 2 hours and 24 minutes, which means we have 2 hours and 24 over 60 minutes, hours, which is 2 plus 24 over 60 is 2.4 hours is the time for the first part of the journey. What about the second part of the journey? We need to use this information to find time. Time is distance over speed. Distance is 45, speed is 20. We'll get the answer in hours, which will be 2.25 hours. So the total distance over total time will be 105 over 2.4 was the time for the first part of the journey, and 2.25 is the time for the second part of the journey. So 105 divided by 2.25 plus 2.4, and we get 3. No, we get 22.58 So the rounded off answer will be 22.6. Question number 19. Fritz drives a distance of 381 kilometers in 2 hours 18 minutes. He then drives 75 kilometers at a constant speed of 30 kilometer per hour. Calculate his average speed for the whole journey. So it's pretty much like question number 19. I won't be doing it. You attempt it on your own. It's exactly like question 18. If you have any problem, just leave me a text. Question number 20. Olaf runs from A to B at a constant speed of 4 meters per second. So I can find the time from A to B. Time is distance over speed. Distance was 150 and speed was 4. So time from A to B comes out to be 150 by 4, which is 37.5 seconds. Yes. Then time from, sorry, this was AC. Then time from AB is distance over speed, and speed from B. Oh, 1 second. Sorry, this was actually from A to B. But let me redo this question. I've made some mistakes. Okay, so time from A to B is this time. So and the speed is 4 meters per second. So the distance here is 120 and the speed is 4. So 120 by 4 is 30. The time taken to travel from A to B is 30 seconds. Then from B to C, so time from B to C will be 180 over 3 meters per second, which gives us 60 seconds. Next, his average speed for the whole journey is 3.6 meters per second. So average speed is actually total distance, which is 150 plus 120 plus 180 over total time. And I have the time for the first part of the journey, then the second part of the journey, but I don't have the time for the third part of the journey. Let's find that. Now I'll apply algebra and find x. 150 plus 120 plus 180 gives me 450 over 90 plus x. Rearrange and solve. I'll do 450 over 3.6 minus 90, which will give me 35. So the time for the third part of the journey comes out to be 33.5. No, this was 35, not 3.5. So calculate his speed when he runs from C to A. So from C to A, the distance is 150. So the speed is distance over time, 150 over 35, which rounded off will give us 4.29. Okay, question number 21. Every Monday, Seema travels by car to the library. The distance is 20 kilometers and the journey takes 23 minutes. This is 21. It was looking like 24. Okay. Calculate the average speed for the journey in kilometers per hour. So 20 over 23 by 60. So if you have those new calculators, you'll enter the values like this. Otherwise, just find 23 over 60 first, which will be 0.383333, and then do 20 divided by answer, which will give us 52. Answer for part 1 is 52.1739 kilometer per hour. I think I've copied some wrong answer over here. I'll fix that. Okay, 52.2 kilometer per hour is the answer for the first part. And then one Monday she delays her average speed. She is delayed and her average speed is reduced by 32 kilometer per hour. Calculate the percentage increase in the journey time. Okay, part 2. It's a heavy duty question. It's for 5 marks. Alright, so it says that on Monday she is delayed and her average speed is reduced to 32 kilometer per hour. Calculate the percentage increase in the journey time. So we need the time for the second part of the journey of Monday's journey. So time is distance over speed. Distance is the same, 20 kilometers, over speed is 32 kilometers per hour. So we'll get our answer in hours. 20 over 32 is 0.625 hours. Now we need to compare it to the uh, previous time. So first that time is in minutes, so let's convert this into minutes by multiplying it with 60, and we get 37.5 hours. So we need to find the percentage increase. So this is the new time in minutes. So the formula for percentage increase is increased value over original value times 100. So what is the increase in value? Increase is from 23 we go till 37.5. So the increase is 37.5 minus 23. Over original time was 23 times 100, which will give us 37.5 minus 23 divided by 23 times 100, which is 63.043. We get 63.0% rounded off answer. Question number 22. Question 22, part A. One day Maria took 27 minutes to walk 1.8 kilometers to school. She left home at 07:48. Write down the time when Maria arrived at school. So first we need the time. Time is distance over speed. No, wait. We just need to add 27 minutes to 07:48. So this is 8, 5, 1 carry, 4, 5, 6, 7, 0, 7. So 75 minutes means 1 hour, 15 minutes, which makes this 08:15, which is the answer for part 1. Part 2. Show that Maria's average walking speed is 4 km per hour. Average speed is total distance over total time. How much time has she taken? 27 minutes. Change this into hours first. So write 27 over 60 in your calculators. That's 0.45. Then do 1.8 divided by 0.45 and we get 4 kilometers per hour. Part B. Another day Maria cycled 1.8 kilometer to school at an average speed of 15 kilometers per hour. Calculate the percentage increase that 15 kilometer is on Maria's walking speed of 4 kilometer per hour. So find percentage increase. Percentage increase is found by writing increased value in the numerator over original value which is 4 times 100. So we have 11 over 4 times 100, which is 275% increase. Part C. Sorry, that was B1 and now we're doing B2. Calculate the percentage decrease that Maria's cycling time is on her walking time of 27 minutes. Do we have her cycling time? The No, we don't. We need to find that out from these two values. Another day, Maria cycles 1.8 kilometer to school at an average speed of 15 kilometer per hour. So first we need time from this. So time is distance over speed, which gives us 1.8 over 15, 0.12 hours, and the other time is in minutes, 27 minutes. So we multiply this with 60 to get time in minutes, so it's 7.2 minutes. Next we have to find the percentage decrease. So the formula for that is decrease in value is 27 minus 7.2 over original value was 27 minutes times 100%. So 27 minus 7.2 over 27 times 100, which is 73.3333, so 73%. Part 3. After school, Maria cycled to her friend's home. This took 9 minutes, which is 36% of the time Maria takes to walk to her friend's home. Calculate the time Maria takes to walk to her friend's home. So 36% of some value is 9 minutes. So what is that value? This is simply 9 into 100 divided by 36, which is 25. Question 23. Car A and car B take part in a race around a circular track. One lap of the track measures 7.6 kilometers. Car A takes 2 minutes 40 seconds to complete one lap. Car B takes 2 minutes 25 seconds to complete each of the track. Both cars travel at constant speed. Calculate the speed of car A. The speed is distance over time. Distance of the track is 7.6 kilometer. Time taken by car A is 2 minutes and 40 seconds. We need the time in hours because we need the speed in kilometer per hour. So 2 over 60 will give us hours, and plus 40 over 3600 will give us the hours. So 2 over 60 plus 40 over 3600, which is 0.044444. So a recurring dot on 4. Then we'll do 7.6 divided by answer and we get 171 kilometers per hour. Answer for part A. Part B says that both cars start the race from the same position at the same time. Find the time taken when both cars A and B are next at position S at same time. Give your answer in minutes and seconds. So actually looks like a very scary question, but it's simply asking you to find the lowest common multiple of these two times. 2 hours 40 seconds in seconds, 2 minutes and 40 seconds in seconds will be 160 seconds, and 2 minutes and 25 seconds in seconds is 145 seconds. We need LCM of 160 and 145. Let's do it over here. 160 and 145. Let's start dividing this with 5. 160 divided by 5 is 32, and 145 divided by 5 is 29. Next, we can't divide it with the same number, so let's divide it. We will just use 29 because 29 is a prime number, and just let's then use 32 to get 1 so we get 32 times 29 times 5, which is 4640 seconds. So after 4640 seconds, both cars will meet again at the same position X. Now give your answer in minutes and seconds. So simply divide this with 60 and we get 77.33333 minutes. Now press the key I told you about, this one, and we get 77 minutes and 20 seconds, which is the answer. Part 2, find the distance that car A has traveled at this time. So distance is speed over time. Speed of car A, speed is given, we found speed in part A 171 kilometers over. Now the total time lapsed was 4640 seconds. We need to change this into hours, so divided by 3600. So solve this in your calculators. For my calculator, I'll do 4640 divided by 3600, and then I'll do 171 divided by answer, which gives me, oh, I wrote the formula wrong again. Speed is equals to distance over time. So we're finding the distance. So distance is speed times time. Speed was 171 kilometer per hour and the time is 4640 over 3600 hours. So 4640 over 3600, 4640 divided by 3600 times 171, which gives us 220.4. Question number 24. Part A. Convert 144 kilometers per hour in meters per second. So 144 kilometers per 1 hour. So kilometer needs to be changed into meters. So for that we multiply with 1000. And hour needs to be changed into seconds. For that we multiply it with 3600. So this will give us 144 times 1000 divided by 3600. 40 is the answer for part A. Part B. A train of length 120 meters is traveling at 144 kilometers per hour. It passes under a bridge of width 20 meters. Find the time taken for the whole train to pass under the bridge. Okay, so for the train to completely pass under the bridge, if this is the bridge and its length is 20 meters, if the train is passing from here, for it to completely pass over the bridge or under the bridge, it will be over here. Once it completely passes the bridge, it's moving in this direction, so the length of the train is 120 meters. So find the time taken for the whole train to pass under the bridge. So now the total distance is 140 and we need the time. Time is, speed is distance over time. So time is distance over speed. So the distance is 140 meters and speed of the train was 144 kilometers per hour. So now we need to change meters to kilometers first. So divide 140 with 1000 in the numerator. Divide with 1000 to change this into kilometers. So in your calculators, in the numerator write 140 divided by 1000 and then in the denominator write 144, which gives us 0.0009722222. This will be in hours. The answer needed should be in seconds, so multiply this with 3600. When we multiply the answer with 3600, we get 3.5, which is the answer for 24B. Question number 25. A car of length 4.3 meters is traveling at 105 km per hour. It passes over a bridge of length 36 meters. Calculate the time in seconds it takes to pass over the bridge completely. So again, first find the length of the bridge, which is, note down the length of the bridge, which is 36 meters long, and then the car passes underneath it, whose length is 4.3 meters. So the total length of both of these would be 36, 7, 8, 40.3. Yes, 40.3 meters, and we need the time. Time is distance over speed, and distance is 40.3 meters over speed is 105 kilometer per hour. Now again, first we'll have to change 40.3 meters to kilometers, so divide it with 1000. So in your calculators enter 40.3, this is point 40.3 divided by 1000, then divided by 105. This gives the answer in hours, 0.00383809. Multiply it with 3600 to get the answer in seconds, times 3600, and we get 1.38, which is the answer. Question number 26. Show that 126 km per hour is the same as 35 meter per second. So 126 kilometers can be changed into 126,000 meters over 1 hour can be written as 1 into 3600 seconds. So this should give 35 meters per second. Okay, part 2. The train has a total length of 220 meters. At 9:30, the train crosses a bridge of length 1400 meters. Calculate the time in seconds that the train took to completely cross the bridge. So more or less the same question. We have a bridge whose length is 1400 meters. We have a train which completely passes through the bridge, which means it's here now, and its length is 220 meters. So the total length is 0 to 1620 meters, and we need the time it takes to completely pass under the bridge is distance over speed, and the speed was, this distance is in meters and the speed is in 35 is in meters per second as well. So 35 meters per second. This will give us time in seconds. 1620 over 35, which gives us 46.2857 seconds, which is the answer. 46.3. Question 27. Part 2. The distance from London to Ashford is 90 kilometers. And then a train takes 36 minutes to reach from London to Ashford. Work out the average speed in kilometer per hour. So total distance over total time but in hours. This will give you the answer, and you'll get 150 kilometers per hour. Part 3. Okay. During the journey, the train takes 35 seconds to completely cross a bridge. The average speed of the train during this crossing is 90 km per hour. The length of the train is 95 meters. Calculate the length in meters of the bridge. So first we simply need the distance. Distance is speed is distance over time. So distance is speed into time. The distance is the speed is 90 kilometers per hour, and the time is 35 seconds, and let's change that into hours as well. So over 3600. So 90 into 35 divided by 3600. We get 0.875 meters. Kilometers, which means 875 meters. So from 875 meters, this length consists of the bridge's length and the length of the train. So we're given the length of the train, which is 95. So simply subtract 95 from this, and we should get the length of the bridge, which is 780. Question 28. Length of the train is 210 meters. It passes through a station of length 340 meters. So there's a station of length 340 meters, and the train itself is 210 meters long. It passes through a station at a speed of 180 kilometers per hour. Calculate the number of seconds the train takes to pass completely through the station. So the total distance passed is 0, the sum of 340 and 210, which is 550. Yes, 550 meters. but since the speed is in kilometers, let's kilometer per hour, let's write it as 0.55 kilometers. And then we need the number of seconds, which means we need the time. Time is distance over speed, and distance was 0.55 and speed was 180. So 0.55 over 180, we get this time in hours. So we're getting time is equals to 0.0030 with a recurring 5. Now this is in hours. Change it into seconds, multiply it with 3600, and we get 11 seconds. That's all.